Now here the problem is let z is equals to x plus iy, then z into z bar is equals to I if the first option is real part of z is equals to 0, while the second one is z is equals to 0, while the third one is imaginary part of z is equals to 0, while the fourth one is none of this. Right. Now we have to check what happens if z into z bar is equals to 0. Now for that we will take let z is equals to x plus iy, and we will take the conjugate. The conjugate of z can be represented by means of z bar, that is equals to x minus iy. Now we will multiply z into z bar is equals to x plus iy into x minus iy, that is equals to, we will get it as a plus b into a minus b. We will write it as a square minus iy whole square. We will write it as x square minus iy whole square is I square y square. And we know the value of I square, that is equals to how much it is? Minus 1. So based on that, we will write it as x square, and I square value is how much? Minus 1. So here we will substitute in order to get minus 1 into y square, that is equals to x square minus into minus plus y square. So we got z into z bar is equals to x square plus y square. Now in the problem they gave z into z bar is equals to 0. According to the problem, z into z bar is equals to 0. Just now we calculated the value of z into z bar, that is x square plus y square is equals to 0. So that we can write it as x is equals to 0 and as well as y is equals to 0. Because x square is a square term and even y square is a square term. The least value for the square term is 0. So either x might be 0 or might be y also might be 0, right? Or x y is equal to 0 and y is equals to 0. So we can write it as both of them are is equals to 0. Then as a result, the value of z, as we got in the question as z is equal to x plus iy. Let me substitute the values of x and y here, so that we will get 0 plus I into 0. That is 0 plus 0 is equals to 0. Therefore, we got z is equals to how much? 0. So, if z is equal to x plus iy, if z into z bar is equals to 0, then z is equals to 0. That is a B option.